Good evening, Mr. Markin. I am Fred Ayala. Um, I am in a group with Jashri Emmanuel, Jafari Shah, Keldon Mass, and Chrysalie Banner. They're my group members, and we will be presenting on simple machines. Now, my simple machine that I'll be presenting on is the wheel and axle. And the most common type of wheel and axle that we all know is obviously wheelbarrow. This is my model. Yeah. It works. It works. It stands on its own. It can roll around. And yeah. So the wheel and axle has many concepts that are applied to it, such as force amplification, mechanical advantage, and rotation, friction, and it's also a lever, surprisingly. Now, the type of lever that a wheelbarrow is a secondary class. And it's a secondary class because the wheel, essentially is the fulcrum. The barrel, the barrel, I could call it, is the load, and the handles, okay, when you lift it up, that's the force. And wheelbarrows are applied in many ways. Well, not just wheelbarrows. Wheel and axles are applied in many ways, like real life stuff, situation stuff. They're involved in transportation. It's used in cars, trains, bicycles, unicycles, constructions, obviously, your wheelbarrow. For agriculture, it's used for crop irrigation, animal traction. Excuse me, sorry. It's also used in industrial equipment, along with robotics and automation. Surprisingly, it's used in renewable energy systems as well. So yeah, this is my wheelbarrow. Again, like I said, it works. All the laws that are also applied to it is, hold on. Sorry for that. The two laws of Newton that act upon a wheel and axle are the third and first law. Now, the wheel and axle follows the third law of motion, which states that the reaction force is the driving mechanism. For example, the force of the wheel exerts on the ground is equal to the normal force acting on the wheel. So if I I do this, the force that I am putting on the wheel with my hand, start to hold one hand, that I am putting on the wheel, the handles is going to the wheel, and the wheel is pressing onto the ground. In this case, a glass table. It also applies the first law. When a wagon is moving at a constant velocity, the sum of all the forces acting on the wagon must add up to zero. So this is because Newton's first law states that a body in motion tends to remain in motion or at a constant velocity unless acted on by a net external force. So right now, wheelbarrow, it's in rest. It's not moving. But when I pick it up, this, the wheel, it's moving. It's moving. So yeah, thank you, Mr. Markin, for viewing my my video. I will upload this separately from my classmates, but I will make sure to include their names in this, because it's hard for us to compile all of this because we live in far away places, and I don't have a working laptop right now, so I can't necessarily use stuff like Canva or Zoom to help present. So yeah, this is my wheelbarrow. Thank you once again, and good night.